All right, class, here's a quick video talking about the electron energy levels and how the different energy levels are populated. Let's watch a few minutes first.
The first electron can hold, or first energy level can only hold 2 electrons. The second energy level can hold only 8. And the third energy level can only hold 18 electrons. Let me show you a picture of that. Okay, so here's our picture of the atom. Here's the nucleus right here. Each of these rings represent energy levels where the electrons are orbiting. So in this first circle right here, notice there are only 2 electrons. And then in this second circle, you have...
So we're seeing the same diagram we've seen in a couple of the slides. This shows the nucleus, of course, and we see the first energy level containing 2 electrons, the second energy level containing 8, and the third energy level containing 18, also known as electron shells. Those terms can be used interchangeably. We're going to talk about focusing on examples that don't cover the full 18, sorry to hesitate, the full 18 in the third shell, and we'll talk about that momentarily. But just let's take a peek here. 2, then 8, and then that third shell containing
2, 4, 6, 8 electrons. And then in this outermost one, there are a total of 18 electrons in the third energy level. So I'm going to make a chart listing the energy level against the number of electrons. And let's see if we can see a general trend.
We can take a peek at his chart. I don't know if we're not going to, well, we'll take a peek at his math just for chuckles.
Do you see a pattern? The first energy level, we can put 2, second 8, third 18, fourth 32. So as the energy level increases, we can put more and more electrons.
So not really part of our lesson this week, but there's a easy mathematical formula that allows you to determine how many electrons are in a given shell. We're only going to focus on the first 3 shells, so we're not really going to need to get into a mathematical formula, but let's take a look.
Electrons in. And in fact, we can even use a formula to predict the number of electrons that can fit into a shell. The formula is...
So here's his formula. He uses n to refer to the energy level he's talking about. So for example, if the energy level 1, n equals 1, 1 squared is of course 1. So 2 times 1 is 2. So 2 electrons in the first energy level. He then focuses on the second energy level, I think in his example here. So n would be 2. N refers to the energy level, so n would be 2. 2 squared, oh, I'm sorry, he's referring to the fourth energy level. Let's use the second energy level. So 2 squared would be 4. So 2 times 2 squared, 2 times 8 for the second energy level. Sorry, 2 times 4 is 8. Apologies, folks. Third energy level, 3 squared is 9, times 2 is 18. Fourth energy level, 4 squared is 16, times 2 is 32. So apologize for this little digression. Let's take a look at, we're going to focus very much on atoms of this size and smaller. It's sort of pertinent to the proceedings this year to consider energy level 1 having 2 electrons, energy level 2 having 8, and to consider examples where energy level 3 has 8 or anything smaller than this. So we're going to, in a sense, set this as the upper limit of what we're going to think about for the time being, models of this size. This happens to have 18 electrons, not related to the 18 that the third energy level contains, because if we fully filled the third energy level, we could have 18 in it. But we're going to consider examples of this size and smaller. So 2 in the first energy level, 8, and then 8 in the third energy level. Same number in the second and third energy levels. We're going to do this for reasons that will become a little bit clear in the next lesson or two. Okay? All right, so that'll wrap up our video, and we will go ahead and proceed with the presentation now.